Hi and welcome to this video about writing a keylogger. A simple keylogger, but a keylogger nonetheless. So how do we do that? How do we create a keylogger? Something that logs keystrokes made by user in any application. So here's one way of doing that. This is by calling the function setWindowsHookEx that allows us to install various types of hooks that can be attached to every process that is bound to the current desktop, including a keyboard hook. In fact, I demonstrated a similar idea using this API in an earlier video where we hooked certain messages. In fact, we did hook some messages related to the keyboard. So this option is very powerful and very precise because for every message that appears in the message queue, you get notification exactly when the user presses a particular key. And so that's nice and that's definitely very powerful. However, it does require you to provide a DLL that is injected by the API into all the processes that are bound to the current desktop and have any UI elements in them, which means that you might be a bit visible, maybe more visible than you'd like, because now your DLL is in many processes within their address space, and maybe some anti-malware solution can find that you want to test your system against malware solutions, and they might be able to recognize that fact. So there's another way to go about it, which is using an API called getKeyState or getAsyncKeyState. In this case, there's no DLL injection that is happening. However, the downside is that it's unsynchronized with the actual keyboard use. So you basically are checking the state of the keys from a hardware perspective. And then you have to make sense of that and somehow correlate with what is actually happening in terms of keys. We'll see what complications that might provide. But it's definitely easier to implement in the sense that it's something that you can do in whatever application and it will affect anything that is running on that desktop. In theory, there's a third option, which is using a keyboard filter driver in kernel space, but that's something I'm not going to discuss, and it's probably overkill for these kinds of things because the ability to inject a driver into a system is much more problematic than just running some application. So let's see how we can go ahead and do something with that. So I have my usual Visual Studio open here, and I've just created a new application as I typically do. And what we want to do here is to have a loop. We must have a loop because we have to call the function getKeyState in a loop every so and so often to get the current state of the keys. And so here's the function getKeyState. Let's see what it actually requires. As you can see, the way it works, you provide some kind of key code, and that key code is being checked to see whether that key is being, the state of that key being pressed or not, things like that. So it's not about getting the entire set of keys that you might want to get. That would be definitely easier, but it's not the way this API works. It returns a short value. This is a 16-bit value where if the most significant bit is 1, it means the key is pressed. Otherwise, the key is not pressed. And so we'll have to kind of check all possible or interesting keys that we might want to capture in some way or another. And so the first thing we can do is to go with the letters keys. And so the letters being A to Z. So I can just create a loop here and check the keys here. And so the idea here is that the virtual key code that getAsync or getKeyState functions require happen to be the ASCII codes for the standard, many of the standard keys like letters, but for special keys there are special values. So technically, if I provide getKeyState provide I to getKeyState, it will return me the state of this particular key. Now notice I have to use capital letters here, and that's because the ASCII character that is being used here is 65, where 65 means the A key. It doesn't matter if it's currently supposed to be a small letter or a capital letter, that's the representation of the key itself from the hardware perspective. And so it must always be capital. So I'm just using that to make it slightly more easier to understand. So if getKeyState returns the high bit as set, which we can check using the AND operator with 8000, that's the highest bit in a 16-bit value. If that is greater than 0, then we have the key being pressed. Another way of doing that is to check with the less than 0, because short is a signed value, and if the high bit is set, that means it's a negative value, which means it is being pressed. If this is the case, what I'm going to do, I'm going to print this character to the console. Obviously, in a real-life application, you probably want to do something more interesting, such as saving the information to a file, sending that through the network, or whatever that may be. But for testing purposes, it's easy to just print it to the console, see if we get what the actual user has pressed. So once we have that, there's no need to actually check for other keys, because there's no way they're being pressed, or probably not being pressed. Maybe they're actually being pressed. You can press multiple keys, but probably we just want to get the one. Typically, users don't hit multiple keys at the same time, especially not in cases that are interesting from a security perspective. Maybe you want to capture usernames and passwords, things like that, which people typically type one character at a time. But you can try other variations if you want to. Another thing we might want to do is perhaps do some kind of sleep, but let's start with this very simple application. I'm going to build that. I'm going to press Ctrl F5 to just run it. And what we have here is an infinite loop that basically just goes ahead and checks the key state of all the letter keys. So here's Notepad here to try this out. I'm pressing A, and notice what we get. We get like many A's. Here's B, C, and this is completely crazy. That's because every time I press the hardware key, it's not just a very simple press, because it's not just so minimal. It actually takes a few milliseconds for me to lift my finger off the key, and at that time the get key state continues to return that the key is pressed. So obviously you probably want to put some delay here anyway, because we don't want to have the thread like consume 100% of CPU cycles, which would be very easy to detect, and it's also going to perhaps interfere with the user's normal work. Let's do a little sleep here. So I'm going to press Ctrl F5 again to try this out. So here's my Notepad. I'm going to type keys. So this is better. We'll still get repeats, more repeats than we actually need. And notice that if I use space, we don't see the space. And that's because we didn't check the space here. And notice the letters are capital letters. If I use capital letters explicitly by pressing the Shift key, we will get the capital letters always. If I don't use the Shift key, we still get capital letters, and that's because we didn't look at the Shift key, which of course we'll have to do. So let's try to make this a bit better. So first, let's have another sleep here. Maybe we should have another sleep to make sure to at least to minimize the idea of getting these multiple keystrokes. That might be a bit better, but maybe you want to find something a bit more robust, which I'll discuss a bit later. But now let's just write something like hello world. And well, I tried to write hello world. Notice that backspace also doesn't get properly caught, which you should actually do in a real keylogger. So I had this hello world weird here. So here's another one. And so it kind of works. Again, we still have just capital letters, and sometimes we get repeated characters. It's not ideal, but it's something to start with. Okay. So let's continue and let's try to make this better. So first thing we want to do is to check the state of the Shift key. See if it's being pressed, and so we can decide whether to show a small letter or a capital letter. So just like we did with the letters, there's get key state again. So we're just going to call this function, this time with a particular value. You can see there's a VK here, which is short for virtual keys, which is a way to identify various keys, especially the special ones. So here's a Shift, for instance. There's a Shift key here. Notice there's L Shift and R Shift as well. So there's a way to distinguish the left Shift key from the right Shift key, because these are different keys on the keyboard. But fortunately, VK Shift just says whatever Shift key is pressed. If this is the case, I would like to get that notification. So it makes it easier if I don't care about the actual Shift key that is being pressed. I'm going to say if this is less than 0, then obviously the Shift key is pressed. And again, the other way of doing that is doing something like this, doing an AND operation with 8000 hex. But I'm going to stick with less than 0, seems to be a bit easier to write. So now in our loop here, we can say if the key state is, if this is pressed, then we need to check the shift state. If it is shifted, then it's actually a capital letter. Otherwise, it's a small letter, and the small letter just has a bit 5 set. So if you can just look at the ASCII character set, you see that A starts capital 65 and the small starts at 97. So if you just subtract that, it's 32. So you can also add 32 here if you prefer. If it makes your makes you feel better, you can use plus here, or operator is the same thing in this case, just lighting up that particular bit. So whatever makes sense to you, it's fine in this case. Okay, let's give it a shot. So here goes, here's my notepad, let's type something. So if I do something A, B, C, D, E, we can see small letters. I'm going to type capital letters now by pressing Shift. You can see we get the correct information with the duplication here and there because maybe our slip is a bit too short. But what happens if I press the caps lock? If I press the caps lock and then do A, B, C, D, I should see the capital letters, but I see small letters, which means we still have a bug here. We have to take the caps lock into consideration. So if I press Shift here with the caps lock, then I write something, we get small letters, but in fact, our application, the keylogger, is confused and shows that as capital letters. So we need to fix that as well. By the way, everything I'm showing here has nothing to do with Notepad. You can take something else, like say this particular Word application here. So that's Word, and I can type with Word and get the same kind of thing. So if I type with Word, like something in Word maybe, we get the same thing. So it works on any application, anything that the user actually is typing at any given point in time. So I'm just using Notepad here as a convenient way for testing, but it can work on any application, web browser, whatever is currently in keyboard focus from the user's perspective. So we also need the state of the caps lock. So get key state is again is the one to call, and the virtual key here is called VK capital. But in this case, this is a toggle kind of key. It's not the same as, it doesn't work in the same way as a shift and control keys. It's something that toggles a state. And so in this case, the documentation says that the lowest bit is the one indicating whether it's toggled or not. So we have to check this bit and make sure that it is 1. That's one way of writing it. And so if this is the case, then the caps lock is toggled. And so what you need to do here is to take both of these into consideration. And here's an elegant way of doing that by using the XOR operator. So the XOR operator takes 2 bits, in this case 2 booleans, which is close enough, and returns 1 if the shift key is pressed or the caps key is toggled, but not both. So if both of them are 0, both of them are 1, we get to the small letter. But if either one is pressed then or toggled, then we get a capital letter. So that's exactly what we're after. Let's make sure that actually works as expected. So first, let me just clear everything here. And you can see that we see this clearing here. Let me just change the order here. So if I press A, B, C, D now, we get small letters. I press Shift, we get capital letters. I'm pressing the caps lock and just using some keys, we get capital letters. And if I go ahead and press Shift while the caps lock is also set, then we get small letters. So it works as expected, it works correctly now, which of course is a good thing. So we've dealt with that. What else? We've seen that spaces don't work, so we have to do something about space. So the basic idea is going to be the same. It's about, well, need to remove the caps lock here. So we have get key state. This time there's VK space. If this is pressed right now, I want to do the same thing as previously, but since space is simpler, it's just a space. So just print the space here and have some sleep. And then just let's go with continue and continue to the next iteration. So that's for sleep. Sorry, that's for space. We can do the same thing for enter, for the enter key. So you can do VK return here. And if this is the case, let's just display \n. So you get the idea. For certain special keys, you have to write a specific code. I'm doing a little copy paste here. You can definitely write something a bit more elegant, but for simplicity, I'm going to stick with this simple copy paste. What else? We don't have any numbers right now. So we need to deal with numbers as well. So let's go ahead and do that. Let's copy some code here. So if we have numbers, again, numbers have ASCII codes from 48, which is 0, to 57, which is 9. So I'm just going to use this shorthand to provide the characters themselves, and the compiler will turn them into their ASCII or Q equivalent. And so if this is pressed, we want to display the thing, display this I. And this seems to be kind of fine, but maybe not really. So let's see what happens when we try this out. So here's my application, here's my notepad, and notice that enter works now, so we can do stuff. We can press enter, and you can see numbers do show up, but what happens if I press shift? If I press shift, I'm supposed to get these characters which are shifted. You can see them in notepad correctly, but our keylogger misses them entirely because it doesn't look at the shift key at that point in time. So obviously we have to fix that as well. So now we have to say, well, what do we get here in the key? It really depends on shift. If the shift key is pressed, then we have to do something else. Otherwise, we'll take the character as is, as the actual digit is. So what is that something else? Now, if you look at the set of the keys that you have with the shift, like the exclamation mark and so on, you might hope that they're also in ASCII order in the ASCII character set. Unfortunately, they're not. So we have to create a mapping. Let's call that numeric shift. We have to create a mapping that maps between 0 to 9 to the actual characters we want to display in case the shift key is pressed as well. So we start with 0, and shift 0 is actually the closing parenthesis. Then we have 1. 1 is the exclamation mark, if I can type correctly. Then we have the next one is the quote character. The next one is the pound, this kind of pound sign. And then we have the dollar sign. Then we have the percent sign. And then we have the hat sign here, or the XOR operator for C and C++. We have then the ampersand, we have the asterisk, and finally for 9 we have the open parenthesis. So as it happens, the order of these keys in the keyboard is not the same as the order in ASCII, so we have to do this kind of thing to provide this mapping. So here I'm going to say if shift is pressed, then we're going to take the information from the mapping by taking the value of I and subtracting a 0 and its ASCII equivalent. So if we press shift 0, then this is going to be 0. So we're going to take the first one. If you press the shift 1, that's going to be a 1. So we get the index number 1 from the shift numeric shift array, and so on. So this should do the right thing. Let's try it out just to make sure. So here's our application again. So if I just use the normal numbers, we get the normal numbers. But if I go ahead and go with shift, then you can see we now get the correct values, like so. So you can see the idea here is to deal with all these characters as needed. For example, even right now, we still don't deal with all characters. If I write something like hello world, notice the comma is not shown up. The exclamation mark is now shown correctly, but the comma is not shown because we have to deal with that explicitly, and other symbols as well, like the colon, the semicolon, and anything else that we might want to capture, like brackets here. Again, they're not captured because we didn't do anything to get to them. So we have to build all that infrastructure into our keylogger. That's just part of the way this should work. And so, as we've seen, there's some nuances here, and one of them is this sleep thing that I'm doing here from time to time, and you can see that the sleep is not necessarily exactly right. And of course, you can try to tweak with these numbers, like change them in some way to try to make it better, but it's actually not going to be very easy, and that's because some of these things are configurable. So notice what happens if I press a key and just hold it. So what happens that in the first, after the first after I just press it, there's a short delay, and then there's a different delay, a kind of repeat delay between the subsequent A's that appear. And this is in fact configurable by going to the keyboard applet in the control panel, and the user can configure that whatever they like in order for them to get the behavior that they like. Which means that even if you try to find the correct values here that work on your system, it doesn't mean it's going to work the same on another system because the configuration might be different. So what you want is probably something more dynamic to get this information. This information in fact is available, so you can get it using a function called system parameters info. So in general, system parameters info is a way to get and set various system-wide parameters. There's a long list which of course is documented. And what we want here is to get the delay, or maybe the initial delay and then the repeated delay that we want. So we need this initial delay and then the repeat delay. We need those two values somehow. And so they're available here. And so if you go to SPI get a keyboard speed, for instance, this will give you the repeat delay. That is the delay that happens after the first character is pressed, or the first time the key is pressed. There's some other values here which are of no interest. So that's one value you can get. The second one is the delay. That is the initial delay before the repeat begins. So you can get that as well using delay, which is get keyboard delay here. That's the value. So we get this information into these two variables, and now we can use them inside these sleep operations. And so it does require some management, because we need to know when the first key is pressed, and then make sure that we use the initial delay, and then for subsequent iterations of the loop we want to use the repeat delay. So it does include some extra complications here, and I'm not going to do that here. I'm going to leave that as an exercise for the interested viewer, but that's probably the better way to go. It still might not be bulletproof, but it's definitely going to be better than try to guess some number that might work kind of fine on your system, but it might not work in exactly the same way on other systems. So there you have it. You have a simple keylogger that you can use to log anything that you want in terms of what the user is pressing right now. It just needs a bit of extension to cover all other keys of interest, like the comma, as we've seen, that is not being covered right now. And the most probably difficult part here is to make sure the delay is just right, so that we get the correct information, not get various repeats which we don't want to get. On the other hand, we don't want to miss keys if we sleep too much. So there's a balancing here, because again, if your point or your goal is to see all these keystrokes as accurately as possible, you have to do some extra work. And as I mentioned at the beginning, the other way is using SetWindows HookieX, which I also recommend you to try out. You can start with that video that describes how to use SetWindows HookieX, and then extend that to all the applications on the current desktop.